Hello, students, and welcome to today's topic on acceleration. If you wish to skip the explanation on acceleration and want to dive straight into the numerical problem, please use the timestamp in the description. But I would suggest to not to skip anything in this video and watch it till the end to get the most of it. Last but not the least, do subscribe to my channel to stay connected. Without wasting any time, let's begin. So, what is acceleration? Acceleration is a measure of the change in the velocity of an object per unit time. If you want to write this mathematically, that would be acceleration equals change in velocity divided by the time taken. Well, what does this even mean? If you know the change in velocity of an object and the time taken for that object to move from, say, point A to point B, you can figure out its acceleration. The SI unit of acceleration is meter per second squared. Sports announcers will occasionally say that a person is accelerating if he or she is moving fast. Yet, acceleration has nothing to do with going fast. A person can be moving very fast and still not be accelerating. Acceleration has to do with changing how fast an object is moving. In other words, if an object is not changing its velocity, then the object is not accelerating. So, in other words, the velocity needs to change and not remain a constant, and only then the object is accelerating. Anytime an object's velocity is changing, the object is said to be accelerating. Now, if you don't know what velocity is, please check out my previous video called Speed and Velocity. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. For example, the motion of a freely falling body. On the other hand, an object can travel with non uniform acceleration if its velocity changes at a non uniform rate. Here's an activity for you. So, here it is. In your everyday life, you come across a range of motions in which A. Acceleration is in the direction of motion, B. Acceleration is against the direction of motion, C. Acceleration is uniform, D. Acceleration is non uniform. Now, the question is, can you identify one example each for the above type of motion? You can pause the video here to think of some examples. Did you get some? Great job! So, students, always remember, if an object is not changing its velocity, then the object is not accelerating. Now, let's do a numerical problem on acceleration. So here in our example, we have a situation starting from a stationary position, stationary. So let me just break that down. Stationary means from zero position. Sam paddles his bicycle to attain a velocity of 6 meter per second in 30 seconds. All right. Then he applies the brakes such that the velocity of the bicycle comes down, which is very important. Okay, comes down to 4 meter per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So here we have case 1 where he starts with zero position. That's the stationary position. So let's just say that this is Sam. Okay. All right. So he's just sitting on his cycle right there. Okay, so this is the bicycle, and this is he's starting here at zero position, and he attains a velocity of 6 meter per second velocity in about 30 seconds. So time is 30 seconds. So this is the time, and this is your velocity over here. Okay. Now at zero velocity, I mean, this is the stationary position. So this would be your initial velocity. He started, I'm sorry. So he started at the initial velocity, which is just zero, and then he attains a velocity of 6 meter per second in 30 seconds. This is the time, this is the velocity. All right. Then he applies the brake. So this is case one, by the way. This is case one. So let me just put case one over here. All right, let's just solve both cases. So we'll begin with case one. So we just want to know what is the acceleration in case one. All right, let me just put this up a little bit. I hope you understood the problem. Okay, so I'll use a different color. Now in case one, what is the acceleration? We know the formula. Acceleration equals change in velocity divided by the time taken, divided by the time taken. Now, what is the change in velocity? If you have seen my previous video on velocity, how would you derive at that? You would begin with something called as the final velocity. Well, maybe I'll just put it right over here. So change in velocity, change in velocity is nothing but the final velocity, okay, the final velocity minus initial velocity. That's how you get it. That's how you get the change in velocity. Okay, so change in velocity is nothing but the final velocity minus initial velocity. So in our first case, let me just go up right here. In our first case, it's written here, the final velocity is 6, right? Here it's written right here, 6. So we're going to write here 6 meter per second minus, what was the initial velocity that he started off with? That's nothing but 0. So you can just say 0 meter per second. Okay, so this would be answerable to this one. What do you actually mean by that change in velocity? Okay, change in velocity is nothing but the final velocity if you have that, and if you have the initial velocity, you just subtract those two, okay, and then whatever answer you get, that would be your change in velocity. Now, in this case, the change in velocity is just going to be 6 meter per second, right? Because we started off with 0 meter per second. That was your initial velocity, and then your final velocity in the question says that it's 6 meter per second. So final minus initial, which is nothing but 6 minus 0. The answer is 6 meter per second, and that's the change in velocity divided by the time taken. So what's the time taken over here? I've written in this right here in yellow. The time taken is just 30 seconds, right? So we'll just have to plug it in. We need to write 6 meter per second divided by 30 seconds because that's the time taken. All right. So let me just move this a little bit over here. Right there. And I'm just going to use a different color. So acceleration for case one, this is for the first case. Case one, acceleration is nothing but that change in velocity. And we usually write it like this. Change in velocity is nothing but v minus u. Okay, the v is the final velocity minus the initial velocity divided by the time taken. So just remember this formula, okay? And it'll just get easy then. I just broke this down into v minus u. So we already know what v is. So v is the final velocity, and the u is the initial velocity. Okay, we already got this. Now coming to t, t is nothing but the time taken. So t is nothing but the time taken. All right, so we already came with the answer. V minus u is just 6 divided by that 30, the number 30 seconds. Okay, so let's just plug it in. Oops, sorry. Yeah, so we will just plug it in. Okay, so I don't know why this keeps happening. Okay, yeah, so acceleration is nothing but that number that we got, 6 meter per second divided by 30 seconds. So when you calculate this, you will get the answer as 0.2 meter per second squared. Now that would be your acceleration for case number 1. Now let's go back to case number 2. For that, I just want to go up over here. So for case number 2, then he applies the brakes. Such that the velocity of the bicycle comes down. So it was accelerating, right? He was moving, and now he's applying the brakes such that the velocity of the bicycle is coming down. So basically it is decelerating. Okay, that's just the opposite of acceleration, deceleration. All right, so he is putting on the brakes, and now the bicycle is slowing down to how much? 4 meter per second in the next 5 seconds. So we got case number 2 here. We got case number 2 over there. So let me just write that down. Case number 2. So let's just put it like this. Case number 2. In that case, acceleration would be nothing but that final velocity minus initial velocity divided by the time taken. Please remember this formula. It just gets easy if you remember this. Okay. So for case number 2, what is the for case number 2, what is the final velocity? Okay, let's just start over here. See that? He applies the brake such that the velocity of the bicycle comes down to 4. All right. He's stopping and it's coming down to 4. That would be your final velocity. So you're going to say 4 meter per second minus the initial one. Remember, final velocity minus initial velocity. The final velocity is just 4 meter per second minus the initial velocity. The initial velocity is nothing but this number over here. He started with 6, right? So that's how, I mean, we're just going by from case number 1. In case number 1, he started off with 0, yes, but then he ended with 6. Okay, now for case 2, he has to begin from 6 and then end with 4 meter per second. Okay, so I will repeat this one more time. In case number 1, Sam started with the initial velocity of just 0. That's his initial velocity. Yeah. And then final velocity that he got was just 6 meter per second. That was for case number 1. Okay, this is the initial, this is the final. But the final has now become the initial for case number 2. Okay, so the final which was 6 meter per second, now that has become the initial because he has to start off with some number. So he has to start off from that 6. So that 6 meter per second is now the initial velocity, okay, in case number 2. And then he brings it down to 4. So we got the final as 4. Initial 6 and final 4. So initial is going to be the 6 and final is going to be a 4. In our formula for acceleration, we start with the final minus initial, right? So the final is now just plugging the numbers, now. Okay, acceleration. So v is nothing but the final. What is the final one? In the question you see it's written as 4 meter per second minus the initial one. Remember I told you 6 meter per second. I already explained it why you got the 6 meter per second. That's how you begin with for case number 2. All right. So 6 meter per second, that's the initial velocity. And the final one that you get is just 4 meter per second divided by the time taken. So it's written in the question, he takes about 5 seconds for case number 2. All right. Now we have to just calculate this. So acceleration is equal to, what is 4 minus 6? If you know your integers, you will get an answer like minus 2 by 5, right? Yeah, so let me just put this meter per second, and this is your seconds. Okay, this is your second. Now minus 2 divided by 5, which is nothing but 0.4 meter per second. But don't forget the minus symbol, so you have to write the minus sign right there. Okay, so this is your acceleration for case number 2. Just notice that you got a minus figure here, which means I'll just draw it and show you. So it'll be easier for you to understand. So here it is. Here was Sam. Okay, I'm not going to draw the bicycle, but you get it. Okay, so he started with the 0 velocity. Okay, and then he moves, he takes his bicycle and he moves to around, well, let me just put it this way. This is the initial velocity, this is the final velocity, and the number was 6 meter per second, right? Okay, and then he puts on the brakes and he starts to slow down. This is for case number 1, but for case number 2 he starts to slow down. Now we take this 6 meter per second as the initial velocity, and then he starts to slow down, okay, to about 4 meter per second. He starts to slow down, and just look at the figure. When you're going backward, you will definitely have a negative number, okay, because you are decelerating. This is called deceleration. It's just the opposite of acceleration. So when you're decelerating, you're going to automatically get a negative number. All right, now this is just a pictorial image just for you to understand. So he started with the initial of 0 meter per second, and the final velocity he got was 6 meter per second. This is for case number 1. For case number 2, this is for 1. Okay, for case number 2, he starts off the initial as 6 meter per second and gets the final velocity of 4 meter per second. Okay, we just used these numbers and we came out with acceleration for case number 1, which we got, and we also got for case number 2, which is right over here. We got a negative figure, and I already told you why we got a negative symbol here. It's because he is decelerating. All right, and deceleration is nothing but the opposite of acceleration, and you are going to get a negative figure. I hope this helps you. Thank you so much.